Good evening, guys. Are getting my screen and device? Please confirm. So today is the second session for the Docker and Kubernetes. Actually, Saturday we don't have the session, guys. But Friday we had first session. And in first session we discussed the course content. And in session one, just we discussed about course content, guys. Course content we discussed. Today, second session, guys. If any new members are there, right? There is no demos, guys. There is no demos. Today, I am going to cover most of the things in the Docker. So most of the things I'm going to cover in the Docker, guys. What is application development, right? So what is virtualization? What is containerization? What is the Docker terminology? How to set up the Docker in the Amazon Linux mission? All these things I'm going to cover today itself. So most of the things in Docker I'm going to cover today. So there is no demos, guys. There is no demos. If any new persons are there, please complete the payment process by today EOD, guys. From tomorrow onwards, so we are not going to allow, guys. Right, guys. Fine. So today, what we are going to discuss, guys. First, what is application, guys? What is software application? What is software application, guys? Can anyone please confirm? What is software application? The collection of programs. The collection of programs is called as software project, guys. The collection of programs is called as software project, guys. Software project means the collection of programs. The collection of programs is called as software project, guys. Okay, what software project contains, guys? Software project contains several components, guys. Software project contains several components, guys. The collection of programs is called as software project. A software project contains several components. What components are available, guys? One is front-end component. Second one is back-end component. Third one is a database component. Right? A software, right? The collection of programs is called as software project. A software project contains several components. What components are available? Front-end component, back-end component, database component, guys. See, if you want to develop the front-end component, we need to use some technologies. If you want to develop the back-end component, we need to use some different technologies. For database, we need to use some other technologies, guys. See here, front-end component means what, guys? User interface. This is user interface, guys. Backend component means what, guys? What is the backend component, guys? Right here, business logic, guys. Business logic. Right? Business logic we need to write in backend component. What about database component, guys? Persistence logic, guys. Persistence logic we need to write in database, guys. For the database component. See, guys. So these are the three components we have: front-end component, back-end component, database component. Front-end component means user interface, back-end component means business logic, database component means persistence logic, guys. Like this, we have total three components are available, guys. Three components are available. So now observe carefully, guys. Now observe carefully here. See, guys, here, observe carefully, guys. Here I am going to take, let me go to the paint. See here, we have three components, guys. What three components are there? One is the front-end component. Second one is the back-end component. Third one is the database component. Third one is the database component, guys. Like this, we have three components are available. See, guys, this is user interface, UI. Right, this is the backend, guys. This is backend component. Backend component. And this is what, guys? This is the database, guys. Database. Right, guys. In backend component, what we have, guys? What we have in the backend components? We have web components are available. We have web components are available, and business components are available, and persistent components are available, guys. Web components, business components, and persistent components are available in the backend, guys. See here, we have web components. Web components are available. Business components are available. Business components are available, and persistence components. Persistence components are available. Persistence components are available. So like this, we have backend component, guys. Next, database, guys. Database we have. See, guys, here we will send the request from user interface to this backend component. Right, see here, inside this we have the business logic to communicate with the database, to insert the data, to fetch the data, to update the data, whatever the operations you want to perform. All the logic we need to write in the backend component only. And from our backend component to database, request will go, guys. Like this it will work, guys. Guys, observe carefully. If you open any application, see, guys, let me open the Make My Trip application. Make My Trip application. Here, whatever the user can see on the browser, that is called as front end, guys. Whatever the user can see on the browser, that is called as front end. See here, flight booking, hotel booking, homestays, holiday packages, trains, buses, etc., etc. See, all these things are the front end component only. Here you will click on the flight and you need to give the right from and to addresses, and you need to click on the search button. You will get the flight gate. Whatever the date you have selected, for that date what flights are available, all the flights list you will get it here, guys. See, guys, here I have selected from and right to I have selected, and I have selected the date. Now here I am going to click on the search button. Whenever you clicked on the search button, request will go to where, guys? Right here in the UI, I have clicked on the search button. When you clicked on the search button, request will go to the backend component. Request will go to the backend component. In the backend component, we have written some logic, guys. We have written some business logic. As per that business logic, it will communicate with the database, and it will fetch the data, and it is displaying the data on the browser at here. See, guys, just we clicked on the search button on the UI. Right, one request will go to the backend. Inside the backend, we have written the business logic. Based on that business logic, the request will go to the database, and it will fetch all this data and display on the browser like this. And here in the UI, we are providing the input, guys, from to date, all these details we are providing. Based on the input, what we have provided, that the business logic will be executed, and it will fetch the data from the database, and again it will display on the browser like this, guys. Okay, now observe carefully. So here, to develop this UI part, to develop this front-end part, what technologies are required? To develop this front-end part, what technologies are required, guys? Front-end. To develop this front-end part, what technologies are required? Guys, observe carefully, very, very important. See here, we need HTML is required, guys, and CSS is required, and Bootstrap is required. Bootstrap is required, and Angular or React, and jQuery, all these things are required to develop the front end part, guys. To develop this backend logic, what technologies are required, guys? Java 1.8 version, right here, Spring Boot, right, 3.x version, Spring Boot 3.x version, and here Hibernate, right, 5.6 version something, 5.6 version something. Right, I need all these technologies to develop the backend part, guys. Coming to database, here I need MySQL server, guys. MySQL DB is required. MySQL DB, right here version some 8.5 version something I need, guys. See, guys, all these softwares I need, guys. To develop the front end part, we need all these things. To develop backend, we need all these things. To develop the database, we need the MySQL database, guys. All these things are required, guys. Okay, fine, guys. Here, I have developed the application, guys. By using all these technologies, I have developed one application and I have uploaded the code into GitHub repository, guys. With all these technologies, I have developed one application and I uploaded that code into the GitHub repository. Right, guys. Observe carefully, guys. So now here, my development team is developed the application right by using all these technologies. That front end, back end, whatever I mentioned, by using all the technologies, my development team developed the project, guys. Once the project development is completed, they tested in local mission. Right, it is working fine, and they have uploaded that code into the remote repository, guys. They have uploaded that code into the remote repository. See, this is my development team. And this is my development team. Right, guys, my development team developed the project by using all these technologies. Development team, guys, and they uploaded the code into GitHub repository. Here we have GitHub repository. They have uploaded this code into this source code repository, GitHub, guys. GitHub source code repository, GitHub. They have uploaded the code, guys. Okay. Now, right, guys. Now what we need to do, guys? We need to take that code and we need to run that application in different environments, guys. Now observe carefully. Here I have different environments, guys. Here I have different environments. See here what environments are available. Observe carefully, guys. Here we have different environments, guys. 1 minute. See here we have dev environment is available. And here sit environment is available. UAT environment is available. Right, pre-prod environment is available. Pre-prod is available, and the prod environment is available. Like this, we have several environments are available, guys. Dev environment. Right. Next here we have the sit environment. Next here we have the UAT environment. And here we have the pre-prod environment. And here we have the prod environment, guys. Like this, multiple environments are available, guys. Now here, DevOps team will come, and they will upload the code into this, right? They will deploy the code into all these environments, guys. Here we have DevOps team is available. This DevOps team will deploy the code into all these environments, guys. This is the DevOps team people. DevOps team people will take the code from the GitHub repository and they need to deploy the application in multiple environments for testing purpose, guys. We need to test the application in multiple environments, guys, not in single environment. Before going to prod, before going to live, we need to test that application in multiple environments. Okay, now observe carefully, guys. In my dev environment, I have this configuration. Guys. Linux is available, plus Java. Right, 1.8 is available. Java 1.8 is available, plus Spring Boot is available. And MySQL, right, 8.5 version is available. Perfect, guys. Okay, so now here same configuration. Same configuration is available in sit environment. Same configuration is available in UAT environment. Same configuration is available in a pre-prod environment. Same configuration is available in prod environment, guys. Prod environment also. Right, guys. Same configuration you should have in all the environments. Then only you can run the application successfully. Suppose, guys, observe carefully. Right, in dev environment, we have Java 11. Java 11 is available. Right. In sit environment, we have Java 13 is available. Right. And in prod environment, we have Java 1.5 is available. Java 1.5 is available. Guys, tell me guys, in my system, Java 1.8 is available. See guys, here observe carefully. If you observe it here, in my system to develop the project, I have used Java 1.8, Spring Boot 3.x, Hibernate 5.6 like this softwares I have used. And I have developed the application. That application is working as expected. And the same application I have uploaded into the GitHub repository. From the GitHub repository, DevOps team will take the code and they will deploy it into multiple environments, guys. Okay, fine. Now observe carefully, guys. Right. So here they deployed the application in the dev environment. They said, "Array, your application is not working." They deployed the application in sit environment. They said your application is not working. But in my system, it is working. My system, that application is working as expected. But why it is not working in our system? My system, whatever the application we have developed, that is working fine. But why it is not working in our system? See guys, observe carefully guys. Right here, guys, our application, whatever the application we developed, we need to test that application in all the environments. Right. Observe carefully guys here. Very, very important point guys. Here, this is my system guys. This is my system. Right. This is my system guys. Right. I have developed the application in my system. That application is working as expected. That application is working as expected in my system guys. I have developed the application in my system that is working as expected. Now, one of my friend asked that code guys. My teammate asked that code. Right, whatever the code I have developed in my system, I have shared that same code to my team member also. Same code I have sent it to my team member guys. Same code I have sent it to my team member. So this is my team member mission. This is my team member mission guys. This is my team member's mission. Right, whatever I have, same code I sent it to my team member also. Right guys, he took the code into in his mission also guys. What I said guys, array, this code is working fine for me. This code is working fine for me. This code is working fine, I said guys. Right, same code, whatever the code is working in my system, same code I have given to my team member guys. But what my team member said, this code is not working for me. This code is not working for me, he said guys. Guys, whatever the code is working in my system, that code is not working in my team member's mission guys. What is the reason guys? What is the reason? What I have shared? I have shared only the application code. I have shared only the application code guys. To run that application, whatever the software I have used in my mission, whatever the technologies I have used in my mission, whatever the versions, what Java version I have used, what Spring Boot version I have used, what Hibernate version I have used, what MySQL version I have used, right? Same versions, same softwares, same libraries, same versions, everything should be same in my friend mission also. Then only my application code will work in my friend mission also. But you have some different version. You have some different versions. Because of that versions mismatch, because of that libraries mismatch, that application is not working in my friend mission. Right, now tell me, same application we are going to run in multiple environments guys. Same application we are going to run in multiple environments: dev environment, sit environment, UAT environment, pre-prod environment, prod environment. Suppose, right, whatever the libraries, dependencies, softwares you have in your mission to run that application, same kind of configuration if your friend, right, these environments doesn't have, same kind of configuration if these environments doesn't have, then that application will work guys. Then that application will work. Guys, whatever the application I have developed, same application I need to deploy in multiple environments for testing purpose. But whatever the libraries I have used, whatever the versions I have used, whatever the dependencies I have used, right, same should be available in all these environments also. Then only my application will work. If there is any mismatch, then this application is not going to work in these environments, guys. Is it correct or not? Guys, respond. Is it correct or not? Right. Then now tell me, Is it possible to share all the softwares, all the dependencies, all the libraries, everything to these environments case? Is it possible to share everything? Is it possible to share all the libraries, whatever I have used, all the softwares, whatever I have used, all the dependencies, whatever I have used in my system? Is it possible to share those things also? And if one machine you can share, guys, here multiple environments are there. It is very difficult to share all that information. If you want, you can share the code, but if you want share entire configuration, it is very difficult, guys. Understood? Is it clear, guys? It is very difficult, guys, right? So to overcome these problems only, Docker came into the picture. To overcome all these problems, Docker came into the picture, guys. In Docker, what we are going to do, guys, whatever the application code you are using, whatever the softwares you are using, whatever the libraries you are using, whatever the dependencies you are using, everything we are going to package as a Docker image. Docker image is nothing but what? A package. Docker image is a package, guys. It contains application code and softwares, dependencies, libraries, entire configuration. Entire configuration we are going to package as a Docker image. If you have the Docker image, you can run that Docker image in any environment. You no need to think about what softwares are available, what libraries are available, what dependencies are available. Everything is available in the Docker image. Just take the Docker image and run in any environment. It will work, guys. If you want to share everything, entire configuration manually, it is very difficult, guys. That's why Docker came into the picture. By using Docker, what we are doing, we are going to package. We are going to package everything along with application code. To run that application, whatever the softwares are required, whatever the dependencies are required, whatever libraries are required, everything we are going to package as a Docker image, and I will give the Docker image to you. You can run that Docker image in our system. It will work as expected, guys. That application will work as expected. Is it clear, guys? Why Docker is required? If you want to share all these things manually, it is very difficult. That's why we are packaging everything to run our whatever we require to run our application as Docker image, and we will give the Docker image. They can run the Docker image in their machines, guys. Is it clear, guys? Guys, respond. Why Docker? Is it clear? Right, guys. Now observe carefully, guys. Now observe carefully. What is Docker, guys? Docker is a containerization tool. Now Docker is available. That's why we are using Docker. Before Docker, what we have, guys? Before Docker, what we have, guys? We have virtualization concept. Before Docker, people use it to work with virtualization concept, guys. Earlier, we don't have this containerization. We have virtualization only. People use it to work with that virtualization concept only. What is virtualization, guys? What is virtualization? What is virtualization, guys? What is the virtualization? See, guys, earlier we have this problem, guys. Earlier we have this problem. To overcome this problem, earlier virtualization came into the picture, guys. Earlier virtualization came into the picture. What is virtualization, guys? To resolve this problem. To resolve this problem, people will go for virtualization, guys. And in virtualization, what we are doing, guys? We are taking one mission, guys. Observe carefully, guys. This is very important. In interview, they will ask what is virtualization, what is containerization, guys. See here, we are taking one mission, guys. Here, we are taking one mission. So, inside this mission, we have one software, guys. Here, we have software, guys. Here, sorry, operating system is available. When I'm saying mission means it have one operating system. That operating system, we will call it as host operating system. That operating system, we will call it as host operating system. Host operating system. Okay. See, guys, we are taking one mission. In this mission, we are installing one software which is called as hypervisor software, guys. In this mission, we are going to install one software. That software is called as hypervisor software. Hypervisor. hypervisor software we are installing in this machine, guys. We are installing hypervisor software. Next, guys, on top of this, you can install any number of guest operating systems. With the help of hypervisor software, you can install any number of guest operating systems. See here, I'm going to take 3 guest operating systems also. This is one guest operating system, right? So here I'm taking one more guest operating system. This is another guest operating system. Right now here, one more operating system. This is the third guest operating system. So like this, I have taken multiple guest operating systems also. See guys, guest operating system. This is one operating system, guys. And here, this is second guest operating system. And this is third guest operating system. So like this, I have taken 3 guest operating systems also, guys. Right. So now, right now here, what I am going to do, guys. Right, in this guest operator, what is the purpose of this hypervisor, guys? What is the purpose of hypervisor software? By using hypervisor in one operating system, we can install multiple other operating systems. By using this hypervisor software in one operating system, we can install multiple other operating systems. Those are called as guest operating systems. Whatever the operating systems you installed, those operating systems, we will call it as guest operating systems. In the guest operating system, we are installing all the development stack, guys. The guest operating system only, we need to install all the development stack. Right? Whatever the Java we used, whatever the Java we need, whatever the database we need, whatever the server we need, everything, right, they are going to install in the guest operating system, guys. Right, to run your application, whatever the Java is required, whatever the database is required, everything they are going to install in the guest operating systems only. Here what we need to take, guys, in the guest operating system, required binaries and libraries we need to take, guys. Required binaries and libraries we need to take it here, guys. Required binaries and libraries we need to take in the guest operating system, guys. See guys, here I'm going to take required guys. Here I'm taking all the required binaries and libraries here, guys. Run your application, whatever the binaries and libraries are required, everything I'm going to take it here. Everything I'm going to take it here. Like this I have taken, guys. Like this I have taken. On top of this, we need to run the application. On top of this, we need to run the application, guys. On top of this, we need to run the application, guys. Here I am going to run application 1, application 2, application 3. Like this, we are going to run the applications on top of this page. See guys, this is called virtualization, guys. This is called virtualization. So we are taking one mission. In that mission, we are installing hypervisor software. What is the purpose of hypervisor, guys? By using hypervisor in one operating system, we can install multiple other operating systems. Those operating systems are called as guest operating systems. In the guest operating system, we are installing all the development stack. Development stack means what, guys? Whatever the Java we need, whatever the database we need, whatever the server we need, everything we are going to install in the guest operating system, right? And they are going to run the application on top of that, guys. Once all the required softwares, libraries, binaries installed in the guest operating system, on top of that, we can run the application, guys. So you no need to purchase multiple computers here, guys. You no need to purchase multiple computers here. By using hypervisor software, in one computer only, we are installing multiple guest operating systems. Here for every, see guys, in previous case, what we have done guys, for every environment, separate mission we purchase guys. Dev environment, separate mission, sit environment, separate mission, say UAT, prod guys. But now, if you go with virtualization, you no need to purchase multiple missions like that. In the single system only, with the help of hypervisor, you can install multiple guest operating systems. On top of the guest operating systems, you can install the required development stack and you can run the application guys. See guys, this is one guest operating system, this is one guest operating system, this is one guest operating system. In single mission only, we are running three operating systems we are running in the single mission guys. See guys, by default you will have one host operating system. This is our main operating system. See guys, in our system, Windows operating system is available. That Windows operating system is called as host operating system, and we need to install hypervisor software. With the help of hypervisor software, you can install the Linux operating system, right? Mac operating system and other operating systems, other guest operating systems, whatever you want, you can install. On top of this guest operating system, you need to install the required development stack. Once that required development stack is installed, you can run the application in all the guest operating systems. So this is called as what guys? Virtualization concept. This is called as virtualization concept guys. Understood guys? What is virtualization is clear? Guys, I will come to Docker. Docker is the containerization platform guys. I will come to Docker, right? So in virtualization, we have some drawbacks. Still in the virtualization, we have some drawbacks guys. To overcome those drawbacks, containerization, Docker came into the picture guys. Right? Earlier, we have first initial days, we have this approach guys. This is very difficult guys. To overcome this problem, virtualization came into the picture. In single mission only, we are installing multiple operating systems and we are running the applications in the single mission only instead of purchasing multiple missions. Right here, what advantages we have with this virtualization guys? Virtualization, what advantages we have guys? Multiple operating systems we can run in the same mission. It is very easy to maintain and recover guys. Maintenance will become very easy if you run multiple operating systems in the single mission. And cost wise also, it is very less cost guys. Lower total cost of ownership guys. Cost wise also, it is very less guys. Multiple operating systems we can run in the same mission. Right? Maintenance will become very easy and the cost wise also very less guys. Why? You don't need to purchase multiple computers. In single mission only, you can run all required things guys. But here we have some disadvantages also. What disadvantages are there? Whenever you are running multiple virtual missions, in single mission, right here performance is not good guys. It will lead unstable performance guys. When you run, if you are running multiple operating systems in single mission, right, it will affect on the performance. Performance is not stable. It will affect on the performance guys. That is one disadvantage. Next guys, hypervisors are not as efficient as host operating system guys. Hypervisor, see guys, here everything is working based on this hypervisor software only. Everything is working based on hypervisor software only. This hypervisor is not efficient like host operating system guys. Hypervisors are not as efficient as host operating system guys. Next problem is when you start the mission, it will take more boot up time guys, right? When you start the mission, right, booting will happen, right? So that booting will take more time if you start the mission when we are running multiple operating systems in the single mission. These are the disadvantages which we have guys. Is it clear guys? What disadvantages are there? One is right, performance issue. Second one is hypervisors are not that much efficient as host operating system. Third problem is right, it will take more boot up time guys. Long boot up process. Approximately it will take more than a minute. More than a minute it will take to complete the boot up process guys. These are the disadvantages we have with this right, virtualization concept guys. To overcome these problems, containerization came into the picture. Here, whatever the problems we are facing with this virtualization, to overcome these problems, containerization came into the picture guys. Containerization came into the picture guys. Is it clear? What is virtualization? What advantages we have? What disadvantages we have? Is it clear guys? Please respond guys. In interview, they will ask what is virtualization, what is containerization, guys. I hope you guys are clear what is virtualization. Okay, fine. So next, guys, what is containerization? What is containerization? What is containerization, guys? What is containerization, guys? See, guys, observe carefully. Instead of installing multiple operating systems, on the single machine, we are going for containerization concept, guys. Right? Instead of installing multiple guest operating systems on the machine, we are going for containerization. See, guys, in the virtualization, we need to install multiple operating system, guys. Instead of doing this, we are going for containerization concept. Whatever the development stack is required for the application execution, we are going to create as one container. We are going to create as one container, and we will execute that container in the host operating system directly. We can run it in the host operating system. Hypervisors are not required at here. You no need to install hypervisor. You no need to install the guest operating system to run our application, because we are not going to follow the virtualization concept. Virtualization concept is outdated concept, guys. Nowadays, no one is using virtualization. That is outdated. It is not recommended. Right? Currently, we are going for containerization concept only. Container means what, guys? It is a package. It is a package, guys. Observe carefully, guys. What is containerization? Observe carefully. Here what we are going to do. See, guys. Here, I have one machine, guys. In that machine, I have host operating system. In this machine, I have host operating system, guys. Host operating system is available. Host operating system is available, guys. Now here, if you want to run the container, container engine is required, guys. Container engine is required. When you install the Docker in our system, along with the Docker, you will get the Docker container engine also you will get, guys. You don't need to install container engine separately. If you install the Docker, along with that, you will get the container engine also. Now here, we need container engine, guys. Here we need container engine, guys. Here we need container engine. Container engine is required, guys. Okay. So now here what we are going to do. See, guys, I think you guys know, right? In Java, JDBC, right? Drivers we have, guys. Right? Drivers we have all those things, guys. Same here. We need container engine to run the containers, guys. Now here, see, guys, what we can do. Right? We can run the containers directly, guys. See here, I'm going to take like this. This is one container. You can run any number of containers, guys. You can run any number of containers, guys. This is one container. This is another container. Right? This is another container. So you can run any number of containers in the single machine, guys. Single machine, you can run any number of containers here. See, guys, what this container contains, guys? Whatever required to run your application, everything, guys, binaries and libraries, whatever you required to run the application, everything is available. Everything is available at here, guys. Right? Everything is available at here, guys. Right? To run the application, whatever you required, everything is available in the container, guys. Application code, binaries, libraries, softwares, everything is available at here, guys. Okay, so now here, just directly you can run the application at here, guys. You can run the application, guys. Application 1, application 2, application like this. See, guys, see, observe carefully, guys. And these are the containers, guys. These are the containers. These are the containers, guys. These are the containers, guys. See, guys, observe carefully, guys. Instead of installing, see, guys, here I am not installing the multiple guest operating systems. Instead of installing multiple operating systems on the single machine, we are going for containerization concept, guys. Whatever the development stack is required for application execution, we are going to create as one container, guys. We are going to create as one container here, guys. One container, right, in the host operating system, guys. You no need to install the hypervisor. You no need to install the hypervisor. You no need to install the guest operating system to run your application, because we are not going to follow the virtualization concept here. Virtualization concept is outdated. Nowadays, no one is using that virtualization concept. Everyone is working with this containerization concept only. See, guys, observe these two diagrams carefully, guys. Observe these two diagrams. Now, let me take these diagrams like this. 1 minute. See, guys, observe carefully, guys. This is what, guys? Virtualization concept. Virtualization. This is virtualization. This is containerization, guys. Containerization. Observe carefully, guys. Observe these two diagrams carefully. In the host operating system, if you go to virtualization, in the host operating system, we need to install the hypervisor software. With the help of hypervisor software, we can install multiple guest operating systems. On top of this guest operating system, you need to install your application. Development stack is binaries, libraries, and everything. On top of that, you can run your application, guys. Where we are installing all these things in the guest operating system only. You are going to run your application in the guest operating system only. So with this, we have some problems, guys. What problems are there? See, multiple virtual machines lead to unstable performance. It will affect on the performance, guys. And hypervisors are not as efficient as host operating system, guys. And it will take boot up time also. It will take more time, guys. It will take more boot up time also. These are the disadvantages of the virtualization. To overcome this problem, containerization concept came into the picture, guys. In containerization, what we are doing, guys, we are not installing hypervisor software. We are not installing guest operating systems. To run your application, whatever the development stack is required, right, and your application code, everything we are going to take as a container, and we are going to run that container in the single machine only. Right? To run that container, we need a Docker engine. We need Docker engine, guys. When you install the Docker in your system, automatically you will get the Docker engine also. With this Docker engine, you can run any number of containers in the machine, guys. See, guys, these are the containers, guys. Inside the container only, we are getting application code, right, required development stack, everything we are getting inside the container only. Just to run that container in the machine by using container engine software. Okay. See, guys, here you are not required to install hypervisor. You are not required to install multiple guest operating system and all, guys. Is this clear, guys? Is this clear? What is the virtualization? What is containerization? Application and application dependencies will be packaged together as a container, and we are going to run that container, guys. In order to run the container engine will be right, available, guys. In our mission, we are going to install that container engine, guys. We are not installing the container engine separately. If you install Docker, along with that, you will get the container engine also. Once a container engine is available, we can run multiple containers, guys. For every application will be executed as one container, guys. Every application will be executed as one container in this mission, guys. Is it clear, guys? Right, guys. Right. Next, guys. Here, what advantages we have with this containerization, guys? Right, containers on same operating system, kernels are light and smaller, guys. Next, guys, better resource utilization compared to virtual machines, guys. And here, start boot up process, guys. It will take less time only to complete that boot up process and all, guys. Right, when compare to containerization and virtualization, containerization is recommended software, guys. Understood, guys? Is this clear? Right, guys. Here, if you observe it here, guys, observe carefully, guys. Observe carefully, guys. Here we have, assume we have the Docker file, guys. We have the Docker file. This is my Docker file, guys. This is my Docker file. Docker file is available. Docker file is available. Right. After from this Docker file, we need to build the Docker image, guys. From this Docker file, we need to build the Docker image, guys. From this Docker file, we need to build the Docker image, guys. Docker image. Docker image we need to build from the Docker file, guys. Once Docker image is created, we need to run the container from the Docker image, guys. We need to run the container from the Docker image, guys. See, guys, Docker file is available. From the Docker file, we need to build the Docker image, and from the Docker image, we need to run the Docker container, guys. This is Docker container. This is Docker container, guys. See, guys, if you have the Docker file, from that Docker file, we are going to build the Docker image. We are going to build the Docker image, guys. Here, build Docker image. Right. You need to run the Docker image to start the container, guys. You need to run the Docker image to start the container. Run the Docker image to start the container, guys. See, guys, this is the architecture, guys. Like this, it will work, guys. Like this, it will work. Now, let me take the architecture from the Google, guys. At what they have given, let me take the architecture from the Google. Docker architecture. Go to images. Yes, let me take some simple architecture. Let me take this diagram, please. Copy image. See, guys, if you observe this diagram, Docker file is available. From the Docker file, we need to build the Docker image, guys. You can keep this Docker image in the Docker hub. Whenever you require, you can pull the image from the Docker hub and you can run the container, guys. Observe carefully, guys, what we are doing. We are creating the Docker file. From the Docker file, we are creating the Docker image. Once Docker image is created, push that Docker image into Docker hub. And when you require to run that application, pull that image from Docker hub and run the container, guys. Run the container. Is that clear, guys? Docker file, Docker image, Docker hub, Docker container. Right, guys. Right, guys. Next, guys, when you are working with this Docker, what terminology we need to use, guys? What terminology we need to use when you are working with this Docker concept, guys? Right, Docker terminology. Docker terminology, guys. What terminology we need to use, guys? See, guys, here Docker files are available. Docker files are available. Next, we have Docker images are available. Docker images are available. Next, we have Docker Hub is available. Docker Hub is available. Next, we have Docker registry is available. Docker registry is available. Next, we have the Docker client is available. Docker client is available. Next, we have Docker container is available. Docker container. So this terminology you should remember, guys. When we are working with Docker, this is the terminology which we need to use. Docker file, Docker images, Docker hub, Docker registry, Docker client, Docker containers. All these things we will use, guys. All these things we will use to work with the Docker, guys. Guys, is this clear? What we discussed, guys? Observe carefully, guys. First, we discussed what is the application, what is software project, and what components are available in the software project. To develop front end, what technologies we need to use. To develop back end component, what technologies we need to use. To develop database, what database we need to use, guys. Right, guys, here we have developed the application and we need to run that application in the multiple environments, guys. When you want to run the same when you want to run the application in multiple environments, whatever the softwares we use in my mission, whatever the libraries, whatever the dependencies I have used to run that application, it is same kind of softwares, same kind of versions, everything should be same in all these environments. Then only you can run the application in all these environments, guys. Next, guys, here we discussed, guys, what is virtualization, what is containerization, right? What is the Docker architecture? All these things clear, guys? All these things are clear, guys? Please respond. Is this clear, guys? Right, guys. Now I want to install the Docker in the Amazon Linux machine, guys. For that, I'm going to create one machine, guys. Observe carefully. Here I'm going to take one machine, guys. Let me go to the instances. Let me go to this instances. I'm going to create one Docker machine, guys. Here already we have. I'm going to delete this Docker VM. I have already in my system. I'm going to delete this Docker VM, guys. Let me terminate this Docker virtual machine. Go to instance state. Terminate it. Alright. So next, guys, let me create the machine, guys. Why it is too slow today? And guys, Docker VM is terminated. Now let me create another machine, guys. Launch instance. Launch instance. I'm going to do the setup from beginning, guys. Please. Oh God, too slow. See here, let me take the name as Docker virtual machine. Docker virtual machine I'm taking as the name. Right, now let me take the Amazon Linux 2 image AMI. Let me take Amazon Linux 2. Next, T2.micro. T2.micro. key pair, existing key pair, I'm taking my Linux, existing key pair, my Linux key I'm going to take here, and here security group, I'm going to take this existing security group only. Here I'm going to select my security group and launch the instance. Right guys, Docker virtual machine is started. Now let me connect with this machine guys. Now let me connect with this machine. Click on connect. Let me open the git bash. You can use anything guys, git bash, mobile stream, putty, anything you can use. I'm using git bash here. Now here take this SSH. Right. So now let me take the update of the package manager. Sudo yum package manager update guys. Update -y. Right. Next guys, once it is done, next install the Docker. Sudo yum install Docker -y. Right guys. Next guys, start the Docker guys. Sudo service Docker start. See guys, Docker is started guys. Now what I am going to do here, EC2-user, right? I'm going to add this EC2-user in the Docker group guys. I'm going to add EC2-user in the Docker group to get the temporary permissions guys, to get the permissions. Now here sudo user mod -ag at group name Docker, and here username EC2-user guys. Next guys, let me check Docker info whether Docker is installed or not. I want to verify. So for that we need to run Docker info command. See guys, see here Docker error guys, right? Permissions issue. Okay, let me check sudo guys. Sudo Docker info. See guys, you are getting the details. You are getting the details guys. See guys, Docker is installed successfully. That's why we are getting the Docker information guys. Okay, right. Once it is done, right, we have some we have some frequently used commands guys. We have some frequently used commands guys. Now let me check those commands guys. Let me check those commands. Docker info we have seen, it will give the information about the Docker guys. Next guys, I want to check, is there any images in my system? Is there any Docker images in my system? I want to check. For that, Docker images command we need to use it. Sudo Docker images. See guys, command not found. Sudo Docker images. See guys, currently we don't have any images guys. Currently we don't have any images at here guys. Okay, so now let me open the Docker hub guys. Let me open the Docker hub. Hub.docker.com. Hub.docker.com guys. Hub.docker.com. docker.com. Open this. This is the public registry, guys. Here you will get a lot of images. You can use these images, guys. For your requirement, you can use these images, guys. Just click on explore. Just click on explore, guys. We need to create the account here. How to create the account, I will show. Right, first let me take one hello world image, guys. Here we have one image which is hello world. Let me take that hello world image, guys. Hello world, guys. Hello world image. See, guys, this hello world image is available. See, guys, this is the simple hello world image. I want to pull this hello world image, guys. I want to pull this hello world image from the Docker Hub. For that, what we need to do, guys? Just this is the command, guys. Sudo docker pull, right, image name we need to give. Sudo docker pull image name we need to give, guys. Then what it will do, guys? It will pull this image from the public registry Docker Hub, guys. It will pull this image from the public registry Docker Hub, guys. Now enter, guys. See, guys, pulling from library hello world, guys. Now successful, guys. It is completed. Status downloaded newer image, guys. Downloaded newer image. Now let me check sudo docker images. Sudo docker images. Yes, see, guys, hello world image is available. Hello world image is available, guys. We have downloaded this hello world image from the Docker Hub, guys. To download the image from the Docker Hub, which command we need to use? Pull command we need to use. Docker pull command we need to use. Docker pull image name we need to give, guys. Now here you can see that image, guys. From where it is downloading, guys? It is downloading. It is pulling from Docker Hub. It is pulling from Docker Hub, guys. Once image is available, now I want to run this image, guys. How you will run the image, guys? By using run command. Docker run command. Hello world. Hello world is the image name. Docker run command. Hello world is the image name. Right. Sudo docker run hello world. Hello world is the image name. See, guys, hello from Docker. See, if you are getting this message, means what, guys? Your installation is a success. You can see, guys, hello from Docker. This message shows that your installation appears to be working correctly. Whatever the Docker installation you have done, that is working correctly. See, guys, if you are getting hello from Docker, means what? This message shows that your installation appears to be working correctly. To generate this message, Docker took all the following steps, guys. This is the internals, guys. Internals of the run command. Interview, there may be a chance to ask internals of the run command, guys. This is internals of the run command. When you run the Docker image, internally these things will happen, guys. Internally these things will happen. What will happen, guys? See, guys, Docker client contacted to the Docker daemon. Docker client contacted to the Docker daemon. Docker daemon pulled the hello world image from the Docker Hub. Docker daemon will pull the hello world image from the Docker Hub. The Docker daemon created a new container from the image which runs the executable that produces the output you are currently reading, guys. Right? The Docker daemon is streamed that output to the Docker client back, guys. Simple, guys. Here Docker client is available, guys. Docker client contact to the Docker daemon, guys. From the Docker Hub, who will pull the image, guys? From the Docker Hub, who will pull the image, guys? Docker daemon only will pull the image from the Docker Hub. Right? Who will start that the image, guys? Who will run the? It will Docker daemon only will pull the image from the Docker Hub, and the Docker daemon only will start the container, guys. Will run the image, guys. Right? Inside the container, Docker daemon is starting the container from the image. Inside that container only your application is executing. Your application is executing inside that container only, and it will provide the output to Docker daemon, guys. That container will provide the output to Docker daemon. Again, that Docker daemon will send that output to Docker client, guys. See, guys, read the steps, guys. Observe carefully. Observe carefully, guys. Here, what is going to happen? See, guys, here we have the Docker client. Here we have the Docker client, guys. Docker client is available. right? Docker client is available at here, guys. And here we have the Docker image, and here we have the Docker daemon also. This is the Docker client, and here we have Docker daemon, guys. We have Docker daemon. Docker daemon is available, guys. Docker daemon is available at here, guys. Alright. So Docker daemon, here we have the Docker hub, guys. Here we have the Docker hub also. Here we have the Docker hub, guys. Docker hub is available. Right. Next here we have the Docker container, guys. Let me take this. Docker container. See, guys, here user will run the command, guys. User will run the Docker run command, guys. And when you run the Docker run command, what will happen, guys? What will happen when you run the Docker run command? What will happen? See, guys, first Docker client will trigger, guys. First Docker client will trigger, guys. Right? So Docker client will connect it to Docker daemon. Docker daemon will download the image from the Docker daemon will download the image from the Docker hub, guys. Docker daemon will connect it to Docker hub, and it will download the image, guys. And it will download the image, guys. It will download the image, guys. And it will start the container, guys. It will start the container here, guys. Right? So container is executing, and it will provide the output, guys. Inside the container only our application is running. Application will generate the output, guys. Again, that output it will give it to Docker daemon. Again, Docker daemon will send that output to Docker client, and the Docker client will give it to, right, this user, guys. Like this it will work. So like this it will work, guys. User will run the Docker run command. When Docker run command is executed, right here Docker client, first Docker client will contact it to Docker daemon. Docker daemon will pull the image from the Docker hub, and the Docker daemon only will start the container. And inside the container our application is executing. It will generate the output to Docker daemon only. Docker daemon will send that output to Docker client. Docker client will display that output to user, guys. So this is the process, guys. See here same steps. Now here you can read the steps, guys. Now here you can read the steps. The Docker client contacted to Docker daemon. Right, the Docker daemon pulled the hello world image from the Docker hub. Right, the Docker daemon created a new container from that image, guys. Docker daemon created a new container from that image which runs the executable that produces the output, guys. Inside the container only our application is executing, and that produces the output you are currently reading, guys. Whatever the message you are reading, right, this message is produced by the container which is started from the hello world image, guys. Who started that container from the hello world image? Docker daemon only. Whatever you are reading, this output is produced by, right, Docker container which is started from the hello world image, guys. Hello world image, guys. Right, the Docker daemon streamed that output to Docker client, right, which sent it to your terminal, guys. See, guys, this is our terminal. Who sent this message to the terminal? Docker client, guys. Who given this message to Docker client? Docker daemon, guys. From where Docker daemon got this message? From the Docker container, guys. How Docker container is created? From the Docker image, which Docker daemon is started the container, guys. And from where Docker daemon is pull that image guys from the Docker hub guys. From the Docker hub, Docker daemon pulled the image and the Docker daemon started the container from the image. That container only produced this message. And again that container given that message to Docker daemon send that message to Docker client. Docker client it displayed that message on the terminal. Is this clear guys? You are getting hello from Docker means your installation setup is successfully working guys. Your installation is working properly. Is this clear guys? Guys respond. When you run the Docker run command, what is happening internally? Guys, before coming to tomorrow session, you guys please create account in the Docker hub guys. Create account in the Docker hub. See here, hello hub.docker.com guys. hub.docker.com. Go to this website and create the account guys. Create the account. Click on register guys. Click on register. It will ask some details guys. Username, email, password. Give these details guys and create the account guys. Create the account at here guys. Is this clear guys? No, nothing. Free guys. Right guys. Guys, tell me what is this Docker file guys? Here I have given the terminology. What is Docker file? What is Docker file guys? Docker file is a file which contains the instructions to create an image guys. If you want to create the image, we require a Docker file guys. What that Docker file contains? It contains the instructions to create the image guys. Right? What it contains guys? Which contains the Docker domain specific keywords guys. Those keywords are very important guys. Right? In demo session I told guys. In demo session already I told from keyword, maintainer keyword, copy keyword, add keyword, run keyword, CMD keyword, entry point, environment, label, user, working directory, expose, volume. All these are the keywords guys. All these are the keywords. By using these keywords inside the Docker file, we need to write the instructions to create the Docker image guys. Docker file is a file which contains the instructions to create a image, right, which contains the Docker domain specific keywords to build the image guys. Okay, next guys, what is Docker image guys? Docker image is a package guys. It's a package which contains everything guys. Software, environment, application code, everything which is required to run your application. To run the application, whatever we require, we are going to package everything as a Docker image. Docker image is a package which contains everything to run your application. Everything means what? Softwares, environments, application code, everything is available in the Docker image guys. What is the Docker container guys? Runtime. Docker container is nothing but a runtime instance of the image guys. A runtime object of the image. Docker container is runtime object of an image guys. If you run the Docker image, container will be created. That's where our application is running guys. Inside the container only our application is running. When you run the Docker image, container will be created. Inside the container only our application is running guys. In simple, container means it is the object of an image, runtime instance of an image guys, right? So next guys, what is registry? What is a Docker registry guys? We can store and share the Docker images guys. Here we have the Docker hub. What is this Docker hub? Docker hub is the public registry. We can store the images. See guys, if I click on sign in, guys, here I have my account guys. Let me go to my account. Guys. Right, continue. I have account in the Docker, guys. I have account in the Docker. In my previous batches, for my previous batches, I have created several Docker images and I have pushed all the images in my account, guys. See, guys, now account name mraju25 came. See here, you can see all the images which I stored in the Docker Hub, guys. Here you can see all the images. See, guys, all these are the images, guys. All these are the images which I have created. All these are the images which I have created, guys. See, guys, here you can see all the images. mraju25 Maven web app, Java web app grid, blue green deployment, it Spring Boot application, it sample image, Maven web application, like that. I have stored several images, guys. I have stored several images. See, in Java web application 1, 80 members are used this application. 80 members are downloaded this application, guys. See, guys, at the same time, here I have uploaded several images, guys. See, Maven web application, 25 members are downloaded. Java web app, green deployment, 3 members. This one is 11 members, like that. Multiple people used these images what I have uploaded in the Docker Hub, guys. See here, Docker registry means what, guys? We can store and share the Docker images. These are the Docker images. We can store and we can share these images, guys. Public repository means what, guys? Docker Hub, guys. Docker Hub is the public repository, guys, which contains all the open source softwares as a Docker images, guys. Now, if you go to explore, here all the open source softwares are available as images, guys. All the open source softwares available as images in the public repository. See, guys, here Nginx, guys. Nginx is available. BusyBox is available. Like Apache 2 is available. See, guys, Apache 2, Ubuntu Apache 2, like this, right? All the open source softwares are available as images in the public repository. This Docker Hub is the public repository, guys, which contains all the open source softwares as Docker images, guys. Okay, right? You can say this Docker public repository as Play Store, guys. In the Play Store, you will get all the softwares or not. Can you able to download the softwares from the Play Store or not, guys? Same way, this Docker Hub also, it contains several open source softwares. You can, as images, guys, you can download those images and you can use for your application, guys. Understood, guys? How you have the Play Store? Same way, guys. Same way you have this Docker Hub, guys. You can download the images from the Docker Hub and you can use it, guys. Private repository means what, guys? Private repository means what? Right, for our internal project purpose, in our company purpose, guys. In our company, we have the repositories, guys. Private registries are available, like Nexus repository, JFrog, right? Docker trusted registry. All these are the private registries, guys. Public registries means Docker Hub, guys. Docker Hub. Docker engine means what, guys? Docker engine. Here we have the Docker engine or Docker daemon or Docker host. All these things are same, guys. Docker engine, right? Docker engine I haven't written. Okay, Docker engine, Docker daemon, Docker host, all are same, guys. Right? Docker engine is a software, guys. It is a software, or we can say it is a program, guys. Using this, right, we can create images and containers, guys. Docker engine only will create the images and containers. Without having Docker engine, you can't able to start the container. To run the container, we should have the Docker engine. Docker engine is the container engine, guys. With that only we can run the containers and we can create the images, guys. We can run the container and we can create the images, guys. Next, guys, Docker Hub, guys. Just now we have seen what is Docker Hub. Docker Hub, Docker registry, Docker images, Docker files, right? Docker, right? Container, all these are clear, right? Fine, guys. Fine, guys. For today, I'm stopping, guys. Right? I will provide the notes, guys. I will prepare the notes here, guys. I will write the notes. Continuation. I will write the notes and I will share it, guys. Okay. Tomorrow we'll discuss the keywords, guys. Whatever the keywords are required to write the Docker files, those keywords we will discuss, and right, we will create some Java web application, Spring Boot application, right, and Python application, right. We will create the Docker files for Java application. We will create the Docker file for Spring Boot application. We will write the Docker file for Python application, and how to run the containers from those applications. Everything we will discuss in tomorrow's session, guys. Everything we will discuss in tomorrow's session, guys. Okay. Fine, guys. For today, I'm stopping. I will share these notes, guys. I will prepare the notes and I will share it, guys. Right, whatever we discussed so far, for everything I will share the notes, guys. Tomorrow we will continue remaining things, guys. Thank you, guys. Good night. Guys, demo sessions are already completed. And who wants to continue this Docker and Kubernetes, guys? In YouTube, who are watching, guys, if you guys are interested with this Docker and Kubernetes batch, and if there is a right number, guys, in description you guys will get the number. Please contact to that number, guys, and complete that enrolling process. Right, from tomorrow onwards, this live sessions are YouTube live is not available, guys. Right, I will share the link. If you guys are contact to that number, if you guys complete your enrollment process, and I will provide the link to join the class from tomorrow. You guys can join and attend for this Docker and Kubernetes sessions, guys. Okay, thank you, guys.